Here we have a problem on derivative. Okay, let's go with the question. If y equals to e to the power of 2x, so that d square y over dx square negative 3 times dy over dx positive 2y equals to 0. Okay, so there is an information that is y equals to e to the power of 2x, and we have to prove the value of this expression equals to 0. And this d square y over dx square represents a second derivative of y. That is, we do derivative of this y for 2 times. And both the times we do it with respect to x, because here we have square for x in denominator. So here this one represents the first derivative of y with respect to x. Okay, now our work is to find the second derivative of y with respect to x and the first derivative of y with respect to x. Okay, now let me take the given equation, that is y equals to e to the power of 2x. Let me find the first derivative. I am going to find derivative on both sides with respect to x. When I find derivative of y with respect to x, I'm getting dy over dx on the left side. Already I know that the derivative of e to the power x is the same e to the x power. So when I find derivative of this e to the power of 2x, I'll be getting the same e to the power of 2x. So by chain rule, when I do further derivative for the exponent 2x with respect to x, I'm just getting 2. So we get dy over dx equals to 2 times e to the power 2x. Okay, now I got the first order derivative of y with respect to x. That is, I got the result for this dy over dx. Now I have to get the second order derivative. So for that, I have to do derivative on both sides of this equation with respect to x. Okay, when I do derivative of this one with respect to x, I'll be getting d square y in numerator. That means I'm doing the second derivative. That's why I square d. Now I'm taking square for x in denominator, because the second time also I'm doing derivative with respect to x. Okay, here on the right side, a constant is multiplied by the variable part. So when I do derivative, whenever a constant is multiplied by the variable, I have to keep the constant as it is. When I find the derivative of this e to the power of 2x, it's the same, that is e to the power of 2x. So by chain rule, when I do further derivative of this 2x with respect to x, I'm just getting 2. So then finally, I'm getting d square y over dx square equals 2. So 2 times 2 is 4, that is 4 times e to the power 2x. Okay, now I got the second order derivative and the first order derivative of y. Okay, now let me take the given equation over here. That is d square y over dx square and negative 3 times dy over dx positive 2y. So now I'm going to find the value of this expression. According to the question, the value of this expression must be 0. Okay, now let me plug in the stuff for this d square over dx square, dy over dx and y. Okay, already we got the result for this d square y over dx square, that is 4 times e to the power of 2x. That I can plug in for this d square y over dx square, that is 4 times e to the power of 2x, negative 3 times, I know that dy over dx equals to 2 times e to the power of 2x. So we get 3 times 2 times e to the power of 2x, positive 2 times y. And for y, we know that y equals e to the power of 2x. So we can plug in e to the power of 2x for this y. So then I'm getting 2 times e to the power of 2x. Okay, now so let's combine this one and this one, because both of them are having the same sign. So positive 4 times e to the power of 2x, positive 2 times e to the power of 2x will become 6 times e to the power of 2x. Negative 3 times 2 is 6, 6 times e to the power of 2x. So 6 times e to the power of 2x, negative 6 times e to the power of 2x will become 0. Okay, now I have shown that the value of this expression equals to 0.